Good day, myself Dr. Jaydev, Associate Professor, Department of Oral Medicine and Radiology, Siddhartha Dental College, Tumkur. Today I am going to take the class on radiation physics. So, what are the learning objectives in radiation physics? To understand the atomic structure, to explain the nature of the radiation, to understand the properties of the X-ray, describe the dental X-ray tube design, then explain X-ray production, understand the factors affecting the X-ray production. So, what is the importance in dentistry to know this? One, radiographs are essential diagnostic tool in dentistry. So, radiation physics explains how X-rays are produced, its properties, its interaction with the matter, and its production factors affecting the X-ray production. So, before going to the production of X-rays, you should know what is how it is produced. So, the matter occupies space and it has mass. So, the matter is composed of atoms and these atoms combine to form a molecules. So, the basic structure of an atom is essential to know. So, the atom composes of the central nucleus and the revolving electrons. So, the nucleus contains protons, neutrons and subatomic particles, whereas the revolving electrons you can able to see that. So, it has K shell, M shell, L shell like this. So, the K shell has the number of electrons is 2, the M shell has 8 and the L shell has the 28. So, this is depend on the formula 2 into n to the power of 2. The K shell is closest to the nucleus, it has a high binding energy, whereas the L shell has a low and M shell has the least. And the binding energy is dictated by the energy needed to remove the electron from its orbit. So, in order to remove the K shell electron, you require about 79 kilovolts of energy to remove that. In the L shell, it requires about 12 kilovolts of it. So, like this, it has a different binding energy for the revolving electrons. This is one of the atom of the tungsten, where it has the atomic number 74 and it has a melting point of about 3422 degrees Celsius. So, before going to this, you should know what are the types of radiation. The radiation, there are two types of radiation, that is the particulate radiation, the electromagnetic radiation. And these particulate radiations, for example, alpha rays, beta rays and the neutrons, and the electromagnetic radiations are photons. Particularly, you have the range of electromagnetic radiations, then the energy transmitted as waves in the form of the electric and the magnetic field at 90 degrees to each other. This is called as electromagnetic radiation. It has no mass and it has no electrical charge. So, it is the electromagnetic spectrum where you can see the radio waves, microwaves, infrared waves, visible rays, ultraviolet, X-ray and the gamma rays. The X-rays fall between the ultraviolet rays and the gamma rays, and it has the wavelength of about 10 to the power of 9 to 10 to the power of 11 nanometers. The properties of the X-rays. What property of the X-ray is utilized in medical imaging? That is the dental imaging. That is the X-rays have the ability to penetrate the tissues, and because of this, the dense structures absorbs the X-rays and it appears as white, whereas the less dense tissues allow the X-rays and it appears as a dark in the radiograph. So, it has a property of photographic effect. This photographic effect it utilized in the developing of the X-ray films. The fluorescence property, this property is utilized in the fluoroscopy and intensifying screens. The intensifying screens are utilized in the extraoral radiograph in the form of cassettes as well as sensors. The ionizing property, the one more is the ionizing property where the energy is, it has a biological effects on radiation, that is it affects the human beings, the tissue damage, it can occur the tissue damage at higher doses, and this property is utilized in radiation therapy for oral cancers. They travel in straight line, due to which you can able to project in particular area you can collimate into a particular area, and this property utilized in doing the radiograph, that is a bisecting angle technique and the paralleling technique. So what are the dental X-ray missions? Dental X-ray missions, we have the intraoral X-ray missions and the extraoral X-ray missions. Basically, the X-ray tube is the same in most of the dental X-ray missions, and the basic structure of X-ray tube appears like this. It has an outer housing which is made up of lead. This is the outer housing. Then it is a position indicating device, and the lead collimator, the aluminum disc. This is a filter. This filters the X-rays, low energy X-rays, and allows the high energy X-rays. The collimator shapens the beam, and it allows the beam in a particular, restricts the beam in a particular area. And there is an oil seal, and inside this you have an oil where it is a mineral oil. It dissipates the heat. Most of the energy in an X-ray tube is converted into heat, and that is dissipated through this oil. And it also helps in restricting the short circuits within the X-ray tube. And you have a step-up transformer and step-down transformers. The step-down transformer is utilized for heating the element as well as to form an electron cloud in the cathode, whereas the step-up transformer is utilized to increase the potential between the two terminals, that is the cathode and the anode, where the electrons are ejected at the target and the X-rays are produced. And if you magnify this, you get a image like this. And this is the X-ray tube of an X-ray. So it has an outer shell which is called as the glass, which is usually a Pyrex glass which withstands the higher temperatures, and this is a cathode. The cathode is usually made up of a molybdenum cup with a tungsten filament. The molybdenum cup helps in accumulation of the electron cloud here, and the tungsten filament is used as well. A tungsten filament and the tungsten target is used because it has a high melting point. That's why we use a tungsten here. And inside this is a vacuum where there won't be any oxidation of the metals, and there is a copper stem with a tungsten target. The copper stem helps in dissipating the heat as well as is a good conductor of electricity. So the electrons are ejected at a high speed to the tungsten target, where it interacts with the tungsten atom. Then the X-rays are produced in all the directions. The X-ray which is produced in direction is utilized for imaging. And most of the energies, that is particularly more than 99% of it, is converted into heat, and less than 1% is converted into X-ray. So the progression of X-ray, when a high speed electron ejects from the cathode to the anode, it strikes the tungsten target, and the kinetic energy is converted into X-rays. So there are basically two types of interactions which is going to occur, that is the Blum-Strolong interaction and the characteristic interaction. There are two interactions in the Blum-Strolong interactions. One is the electrons which is ejected from the cathode interact with the anode tungsten at the nucleus level. It is suddenly stopped and the electron ceases to exist. The most of the energy from this is converted into the X-ray. So this is the one. The second one is the near miss, where it goes nearer to the nucleus and deviates. The higher the deviation, the more the energy of an X-ray photon which is emitted. So there are two interactions in this. So this is the one. Then the characteristic interactions, usually the electron which is ejected from the cathode and interact with the anode tungsten atom, where the electron interacts with the revolving electrons of the tungsten, where it is ejected out, forming a void here. During the ejection, there is an release of X-ray. So the outer orbital electrons, there is a void in the K shell. From the L shell, the electrons jumps to the K shell, where the binding energy, difference in binding energy will be ejected as the X-ray photon. So like this. So outer orbital electrons jumps to the inner orbital electron where the void is there. So the characteristic energy levels which is required for the binding energy, which is equivalent to the binding energy, will be released as an X-ray. So the X-ray which is produced will have the like this, that is relative intensity of X-ray, where this line depicts the Bremsstrahlung radiation or the braking radiation, whereas this particular area of level where you can see that it depicts the characteristic radiations. So heat production is one of the important thing. You should know that more than 99% will be produced as heat, as only a fraction of the energy is converted into X-rays. So we have a lag period for most of the extraoral radiographs where it requires some period of time to expose the another X-ray. So factors affecting the X-ray production, the kilovoltage, milliamperage, the exposure time, the filtration, collimation and inverse square law. These are the factors which is going to affect the production of X-rays. So kilovoltage which controls the energy of the electrons, that is the potential difference between the two terminals it controls. So higher the potential, higher the X-ray energy levels. So it affects the penetrating power. If you have a higher energy of X-ray, it increases the penetrating ability of the photon. Milliamperage which controls only the number of electrons. So the number of electrons is increased or decreased, it only controls the quantity of the X-rays from the X-ray tube. The exposure time, duration of the electron flow, it is only the duration of the electron, whether if you increase the time, the amount of X-rays will be increased, that's all. If you decrease the time, the lower amount of X-rays will be ejected from the particular X-ray tube. The filtrations, why filters are added in the X-ray tube? That is to remove the unwanted X-rays. Unwanted X-rays are the low energy X-rays which has to be removed because it absorbs only in the body and produces the biological effects of radiation. So it has to be removed. So for that we add some thickness of aluminum in the X-ray tube. So it improves the beam quality, and usually it is measured in half value layer. The half value layer is the thickness of the material required to reduce the intensity of the radiation to half of its value. That is, the intensity will be reduced to half of it. That is the half value. The half value layer for different materials is different. The thickness of the different materials is different. So usually it is measured in the equivalent to the aluminum. So we have the inherent filter. There is something called as the inherent filter and the added filter. Whatever we add it to the X-ray mission is the added filter. The inherent filters is already within the X-ray tube. That is the Pyrex glass, the oil seal, all this makes an inherent filters. So that also adds to the filtration of some of the X-rays. So that is an inherent filters which cannot be avoided. Then is the added filters, and if you add it both the things, we will get the total filters. Almost all the X-ray missions depict this inherent filters, added filters and total filters on its labels. Then is the collimation. The collimation in the radiology is a process where it is restricting the size and shape of the beam to the particular area. So it will enhance the image quality, it will reduce the patient exposure. So what is the collimation? There are different types of collimation based on the location of the collimators. That is the diaphragm collimators, which is located just in front of the X-ray tube. This is the diaphragm collimators. Where is the extended collimators? Where is extended as a PID? That is called the extended cone collimators. Based on the shape, there is a round collimators and rectangular collimators. In the diaphragm collimators also, there are round and rectangular shape, whereas in the extended collimators also, there is a round and a rectangular shape. The effective collimation we will get it in the rectangular collimation. So inverse square law, this is one of the most important thing you should know. So usually we have short cone techniques and the long cone techniques. The short cone techniques, the X-ray exposure what we require is less, whereas in the long cone technique, the X-ray exposure what we require is a little more. So that is what it depicts, that intensity is inversely proportional to the distance square of the distance. That is the thing what it depicts. So if you increase the distance, the intensity is decreased. So how much it is decreased is, it is about the square of the distance. For example, at 1 meter the intensity is 1, then at 2 meters it becomes 1/4. At 3 meters, it becomes 1/9, and at 4 meters, it becomes 1/16. That is what it depicts. So, summary, radiation physics explains the principle behind the generation of X-ray tube and in a dental radiography. The understanding of the atomic structure is very important in the production of X-rays and the interaction of X-ray in the matter, as well as the interaction of X-ray in the sensor as well as the X-ray film. The X-rays are electromagnetic radiation, and the properties such as penetrating, the photographic effect, the fluorescence, ionization, and they travel in straight line, all this enable the diagnostic imaging. The X-ray production and the beam quality are influenced by the factors like kilovoltage, milliamperage, the exposure time, the filtration, the collimation, and the inverse square law. Thank you. Any questions you can ask.